Alright, so this is Friday the 15th. You should be starting off with a quick quiz 7.2 with your partner. So spread out throughout the classroom. Please use whisper voices, and you have about 15 minutes to do the 7.2 quick quiz. Miss Stedman, please just kind of keep an eye on time. If it looks like they really need more time, you can give them up to 20. Again, Miss Stedman, please press pause, and then we'll start once they're done. All right. If you are done your quizzes at this point, you should have done homework check number 4, 10 points for doing, 5 points for checking. And then, Ms. Stedman, please take the homework questions at the end of the video. There may be a lot because I know that yesterday my video was not so awesome. So today we're going to be doing 7.3 day 2, which is revolving. All right, so if you guys can get ready to take some notes. So today is, wow, 5th day of taking notes through video. I know this is torturous. I can only imagine. Just so you know, I'm exhausted from making these, and my neck hurts from staring up because I'm short and I apparently can't reach the top of the board, and it's causing me to have a crazy neck cramp. And it is Thursday before my surgery at 7:40, and I have made God knows how many videos after messing up 2 of them. So let's get started. So I'm actually going to just start you off with the definitions, and then we'll talk about what a disk is. D-I-S-K or D-I-S-C, either way. Horizontal axis of revolution, you're going to be doing a rotation. So rotations mean that your cross sections end up being circles, and I'll show you through an animated program, and then Ms. Stedman, if you want to bring over the kind of globe thing in my classroom, or sorry, in my office, it'll also show them. So, a volume by rotation, horizontal axis of revolution is A times B of pi r squared dx. Now, that should look really familiar because that is literally the volume of a shape that has circular cross section. So really, I'm just going to end up writing the exact same thing twice because that's really all you're doing. You're finding the volume of a function whose area happens to be circle. Alright, so with that in mind, we are going to start off with this problem here, going from 0 to pi of sine of x. So sine of pi over 2 is 0, sine of pi and 0 are 0. So it kind of looks like that. I'm going to show you how to make your revolution really easily. First thing you're going to do, reflect it across the x-axis, because we're going to revolve around the x-axis. So I always do this to show how I'm revolving. So you do your revolution, you reflect across the x-axis, and then I show one circle, which is the shape of the cross-section, and one representative rectangle. So that would be here. So that's what causes the circle to happen. So this will swing around, come out the board, and swing back into the board, and that's actually what creates the circle. So Ms. Stedman, I'm actually going to show an animated program, and then if you want to give the students the physical revolution to play around with, it's the blue thing that hopefully you brought into class today. So my picture, awesome. Not so awesome, I'm lying. This is going to be much better. So I want to show you that you're going to be revolving around the x-axis. This is the same function that you have. I am going to physically revolve it. Oh, Lord. I'm not exactly sure why it won't revolve. I'm a little bit worried here. Let's see. So, let's see. All right. Well, there you go. So you can kind of see the disc, the circle, flying through there. Okay? Now, I am sorry. It actually shows usually the revolution really nicely too. But you can see the circles as they fly through that shape. Alright, so what I want to show you is, if I go back, I can physically draw on top of here. This would be the radius. And what I want you to notice is that the radius is the same height as the function itself. This is the representative rectangle that I have you guys draw. The reason why I do that is we did it for area, then we did it for volumes when we were just kind of finding one side of a shape. And then we do it again when we do revolutions, because it'll help you figure out, is it a dx, is it a dy, and it also highlights the radius. So over here, we have the same exact thing again. What I want to show you is that to find the volume from 0 to pi, because it's a dx problem, how do I know it's a dx problem? Because we're revolving around the x-axis or anything parallel to the x-axis. The other way you know, because you're going to draw your rectangle, if your rectangle has a top and a bottom, that is a dx problem. So remember, we're going to do the area of a circle. So to do that, we're going to do the integral from 0 to pi of a circle. The circle area is pi r squared dx, and therefore the only thing you have to figure out is what is the radius. And in this case, that right there is the radius. The radius happens to be the same height as the function, dx. That will give us the volume of that crazy shape, which was shown in here, so that you can see this is what we call a solid. It has no air in the middle. It has no extra space. The whole thing is one big old solid. All right? Moving on. Example 2. Revolving around a line that is not the coordinate axis. So in this case, we're going to take the function 2 minus x squared. Let's see. Now, that would be 1. Substitute in x equal to 1. You'll get these values. Let's see. A parabola with these values. And then g of x equals 1. So here, and then this is where we're going to revolve around. So same exact thing. If you want to see what the shape looks like, you can revolve by doing a reflection across the line of revolution, and then you can draw one full circle, and then one rectangle that represents the radius. So that is my radius. And we're going to put a top and a bottom in it. So we know, first of all, that we're doing a dx problem, and we know that because the rectangle is vertical. If I'm doing a dx, these have to be x values, so I know I'm going from -1 to 1, and this is a dx problem. I know that I'm doing a circle, so there's the formula for a circle. Now I'm going to go down and physically fill out the radius. And that's going to be a little harder for this problem. In this case, the radius is represented by this red rectangle. What's interesting, though, now blue rectangle, is look at where the x-axis is. It's all the way down here. I'm going to actually erase the bottom half of this so you don't even get confused by it. So that blue right there is supposed to be your radius. And that radius doesn't touch the x-axis. And if you remember from when we did area, we actually did a top and bottom to help us figure out the area. Now, that concept works exactly the same way. If I want to find a length, meaning a radius, I can use the concept of top and bottom, meaning the radius in this case is top minus bottom. And in this case, we have that the top function is 2 minus x squared, and that the bottom function is 1. Therefore, I get negative x squared plus 1. And that is my radius. I'm hoping all the connections that I thought I made are being made. Again, kind of difficult through video. All right, try another guy. Revolving around the y-axis. So I have a function root of x plus 2, so that'd be here, until, so y equal to 0 would be this, x equal to 6 is here, and then put in 6 to get root of 4. There we go. All right, so we're going to revolve around the y-axis. So this problem I always have to show you guys because I didn't write it very well. What I want you to revolve is this solid piece. Okay? Now, if you want to see what it looks like, I'm going to make it smaller. Make it skinnier so it fits. And then literally, you would reflect the shape and then draw your circle. That's what it will look like. Now, in terms of what I would do, I would then look at it and say, well, if my circles are going this way, then my representative rectangle would go this way, which now makes it a dy problem. My y values are going from bottom value of 0 up to a top value of 2. Other things I know, if I'm doing a dy problem, we can label these right and left. And pretty much I have everything that I would need. So, circle would be, oh sorry, I did not want to do a and b. We're going a y value of 0 to a y value of 2, pi r squared dy. So, you should be able to figure out that my radius is right minus left, but my right function is this right here. If you remember when we do dy problems, you can't leave a function in terms of x. So, square both sides. Y squared is equal to x minus 2. Therefore, x is equal to y squared plus 2. So my right function, ooh, I just realized that the right function also looks like radius. Let's try to remember that they're not the same thing. All right, so this here is my radius. And my radius would be right function, y squared plus 2, minus the left function, which you don't really need it, but it's 0. So, therefore, I know that my radius is y squared plus 2, whole thing squared dy. Now, if you notice, I am not spending the time to integrate each of them. I'm spending much more time with the setup. It's because half the problems you'll have to integrate by hand, and then half of them you get to do with the calculator. So you'll be using FNInt for a lot of these. This problem, especially if you were to be asked to do it without a calculator, this squared means that I would multiply this out and turn it into a polynomial instead of a squared binomial. You can't use substitution because there's no other y being multiplied. All right, so Ms. Demon, if you could get them to practice these problems, they're just setup problems. You're going to call the starting A, the ending B. Any of these shapes have to be solid, so they do go all the way down to whatever axes you're looking at. So all of these, here, here, and then the last ones would go all the way over to here. All right, so if you could get them to practice these, and then when you're done, I'll go through each of them if there's time. Otherwise, you can kind of fly through the answers for each of them. And the other thing I should mention, if you're using x values, we use a and b for our limits. But if you're using y values, this way, I want you to use c and d. Okay, that's how we know that you're doing dx or dy. All right, so Ms. Demon, if you could please pause. Otherwise, I am going to go through each of the answers. All right, so here we go. In this case, this would be, and you'll notice I always do top, bottom, and this is the radius. How do I know that? Because when I spin this, it causes this circle. If you need to see what what the shape looks like, here it is. All right, so volume is equal to the integral, and it's a vertical, therefore I know it's a dx. If it's a dx, I know I'm going from a to b, pi r squared. So in this case, a to b pi, my radius is the function g of x squared. So there's letter A. Letter B, or number 2, it would end up looking like this. This is my representative rectangle of my circle radius. Top and bottom. Top and bottom. All right, so this guy, volume would equal integral a to b, because it's vertical, dx. My top function in this case is, so pi r squared. So that whole thing inside of here needs to be r. I'm going to do the top function in red. The top function is f of x, minus my bottom function in purple, which is -2. That's how I would find this guy's volume. Number 3. So rotation is about this line. Rotation is about the line y equal to 3. All right, so this is a dx problem. I'm rotating, which means that here's my circle. Oh, wondering what it looks like. There we go. There's my circle, my representative radius, top, bottom. All right, so here's the radius squared. My top function is h of x. My bottom function, 2. This one I'm going to do without drawing the representative rectangle. Sorry, not the representative rectangle, I mean the shape reflected. I'm going to show you that that's the top, that's the bottom, and this is the radius. My volume would be the integral from a to b, because I'm still rotating and doing vertical rectangles, a dx, pi. This whole thing is supposed to be my radius squared. Radius, the top function is 3. My bottom function is k of x. See? So, there you go. Number 5, representative rectangle around the axis of rotation. Axis of rotation over to the shape. There's my representative rectangle. I can tell that that's a dy. Here's my right, here's my left. Oh, if I'm doing vertically, then I said use C and D, meaning horizontal rectangles. I'm doing a dy problem, pi r squared. My radius, my right is my bigger, so f of y, minus my left, which is -5. And then number 6, representative rectangle. It's a dy problem. This is my right, this is my left. Volume is equal to C to D of pi r squared dy. My right function is 3. My left function is g of y. And there you go. All right. There's everything. So if you kind of notice what I was saying, I was drawing my representative rectangles by going from the axis of rotation to the function. Axis of rotation to the function. If I go back to some older ones, axis of rotation to the function. That's vertical. Axis of rotation to function. And that will help you figure out if it's a dx or a dy.